In this module, we're going to look at the nomenclature, specifically the nomenclature of ionic compounds. Ionic compounds, if you remember, are a homogeneous substance composed of more than one element, a metal and a nonmetal. And if we look on the periodic table, the shaded portion is the nonmetals and the unshaded portion are the metals. The metals will get a positive charge and they are called cations. The nonmetals get a negative charge and they are called anions. So we're going to look at the cations first. So on the periodic table, if we look at that first column, the alkali metals, everything in the alkali metals family has a charge of +1. Second column, the alkaline earth metals, everything in that family has a charge of +2. When we get to the rest of the metals, we call those transition metals. For the transition metals, silver has a charge of +1, zinc has a charge of +2, aluminum has a charge of +3. I remember those because they go on the diagonal and their charges go up as the diagonals go up. Every other metal, I have to give you a clue in the name. So there are multiple charges for each of the metals. So for all metals, a charge must be given. Iron 2 has a charge of +2. Iron 3 would have a charge of +3. Copper 2 would have a charge of +2. Copper 1 would have a charge of +1. Whatever number is in the name, that is the charge of the metal. Now let's look at the nonmetals. The nonmetals get a negative charge, they're called anions, and starting with the nonmetals, the nitrogen family has a charge of -3. The chalcogen family has a charge of -2. The halogen family has a charge of -1, and the noble gases have no charge. So let's start putting them together. Ions come together such that their charges cancel each other out. So an ionic compound should have an overall net charge of 0. So we're going to find calcium. Calcium is an alkaline earth metal, so it has a charge of +2. I'm going to combine it with chlorine. Chlorine is a halogen, so it has a charge of -1. It takes 2 -1s to neutralize the +2, so it takes 2 chlorines to balance 1 calcium. So the formula is going to be CaCl2. 1 + 2, 2 -1s, overall neutral. The ionic compounds are named by both of its components. So the first part is the name of the cation, and the cation in this case is calcium. And then the second part is the root name of the anion, but it gets the "ide" ending, so we know that the name is done. So it starts as chlorine, chlorine becomes chloride, and the chemical formula becomes calcium chloride. If we look at a second compound, we can start with iron 3. And if I call it iron 3, that means it has a charge of 3+, and that is our metal. I can combine it with oxygen, and oxygen is a chalcogen, so it has a charge of -2. So if I look at that, it takes 3 oxygens to give us a -6 charge, and that will balance out 2 iron 3s, which has a +6 charge. So we always have to kind of look for least common multiples as we are putting them together. So the formula for iron for this compound would be Fe2O3. First part of the name is the name of the cation, and we said that was iron 3. And in the naming, I have to include the Roman numeral, otherwise I don't know which iron it is. Second part is the root name of the anion ending in "ide." In this case, it is oxygen, so oxygen becomes oxide. So the name for this compound would be iron 3 oxide. Please note that the Roman numeral 3 has nothing to do, or is not the same as the subscript for the iron. It just lets us know what the charge is. Let's do a third one. The ions come together in a ratio to neutralize the charge. Aluminum has a charge of +3, so we're going to deal with aluminum. Has a charge of +3. Nitrogen has a charge of -3 because it's in the nitrogen family, so nitrogen has a charge of -3. In this case, it takes 1 nitrogen to balance 1 aluminum. The +3 and the -3 cancel, so our formula becomes Aln. First part of the name of the anion, which in this case is aluminum. Second part is the root name of the anion ending in "ide," so that is nitrogen, which becomes nitride. So the compound's name would be aluminum nitride. This is basic ionic nomenclature. So this ends the module of ionic compounds.